Okay, in problem number 49, we also have an abstract type of a problem here. It's not easy to see how all the pieces work together. We have a lot of variables in there. So we're given this equation, ax is equal to b minus 5. And what we want to know is, can you select from this list of values given above? Can you select values for a and b that will cause x to become a positive integer? And what I'm going to suggest that might make this problem a little bit easier, because there are many different combinations that we could get for a and b. So for example, I'll just make a list of them over here. If we had values for a and values for b and then values for x. So for example, if a were to be -2, well, b could be -2 as well. A could be -2 and b could be 5. A could be -2 and b could be 9, or a could be -2, b could be 10. As you see, we can go on and on. A could be 5, b could be -2, a could be 5, b could be 5, a could be 5, b could be 9, a could be 5, b could be 10, etc., etc. on both sides there. And so you can see that for each one of those values there, we happen to have 4 different possible combinations. And so 4 times 4 would give us 16 different combinations of A's and B's to plug in. We could go through and test all of them. Or we could do something. Now let's just see. In the first case, if A were -2, so I'll go through a few of the examples over here. If A were -2 and B were -2, then the question is, could x become a positive integer? Would x be a positive integer? We would solve this by dividing both sides by -2. And x in this case, numerator -7, denominator -2, so that would be, as an improper fraction, +7/2, which is positive, but it's not an integer. Again, an integer would have to be a whole number, either positive, negative, or 0. In this case, we're only interested in positive integers. So that combination doesn't work. Now we could go on, we could try the next combination, etc., and see what we would get here. So we're saying that a is still equal to -2, so this is a different example. A is still equal to -2. B would be equal to 5. And then we still have -5 there. So we can see on the right side that we'd get 0. We divide by -2. And anything 0 divided by anything is 0. And so again, it is an integer in this case, but it's not positive. It would have to be greater than 0. So in the first example, we had a positive value, but it wasn't an integer. In the second case, we had an integer, but it wasn't positive. Now we would have to continue doing this, trying all of the different possible values, of which there are 16 combinations for A and B. Or we could do something else that might make our life a little bit easier. And that is, I would suggest isolating x so that we have x is equal to b minus 5 over a. Now, in order to get a positive value, we know that we either have to have numerator and denominator both positive, or numerator and denominator both negative. And to get an integer, whatever the numerator is, has to be evenly divided by the denominator. So, if we let a be -2, so let's see what happens there. then that means our numerator would have to be a negative number that is also even, so that it can be evenly divided by 2. And let's see, are any of the values in the do any of the values in that list work to give us a negative value that is also even? So we could put -2 in there, but we'd have -7. Put 5 in there, we'd have 0. Put 9 in there, we'd have an even value. We'd have a positive value that is even, but divided by a negative will give us a negative. So that tells us that there's no way that we can use -2 to make this work. And so let's try something else. If a is equal to 5. Well, what we need now is we need the numerator to be positive, because we have to have positive divided by positive to give us a positive result. And it has to be the numerator, when we subtract 5 from b, has to give us a multiple of 5. Right? And so -2 will not work. 5 will give us 0, which will give us 0 as a result, and that doesn't work. 9 will give us 4, and 4 over 5 is not an integer. 10 will work. So if a is 5, then b can be equal to 10, and that will work. So 10 minus 5, x equals 10 minus 5 over 5 will equal to 5 over 5 is equal to 1, which is positive integer. All right. Now, there may be other values that will work as well, but actually I think none of them do. There is only one answer that satisfies the above. So this would be for part A then. Now for part B, we're looking for a negative integer. So this time the value has to come out to be negative, and we'll see what happens there. So to get a negative integer, we can use -2 in the denominator. Let's go back to this. X equals b minus 5 over a. So if we try to use if a is equal to -2, so we have a -2 in the denominator, which means that our numerator has to be positive to get a result of negative, and it has to yield an even value, so that when we divide by 2, we get a whole number. So the only ones that will work there, -2 will not work, 5 will give 0, 9 minus 5 is 4, that works, 10 minus 5 doesn't. So if a is equal to -2, b would be equal to 9, and finally x is equal to 9 minus 5 over -2, which is 4 over -2, which is -2, and that is a negative integer. Alright, so this one is kind of tricky, but as you can see, if we make an organized list, we would see that there are 16 possible combinations of a's and b's. We can go through the whole list, or we can solve for x and then try to reason our way through with the different available values. And so I'll plug these values in here. A would be 5, B would be 10, and that will give us an x value of 1. And in the second one, when A is -2 and B is 9, then the result would be x would be -2, and that is a negative integer. So it turns out that each one of the numbers was used exactly once. It would be helpful in this kind of problem if it would state that you can only use each of the numbers one time, and that might make our lives a little bit easier there.